Hello there. Welcome to the semi-live coding section today. My name is James, a software engineer on Firebase. Today, we are going to walk through a Codelab and try out Firebase Performance Monitoring. Nowadays, creating a high-quality app with seamless experience is crucial to businesses. Users might abandon the app and find alternatives if they need to wait too long for a web page or mobile app to load. But if your app is used all over the world, it can be really hard to know if your app performs well for all users. Firebase's mission is to help developers succeed. So we offer a solution called Performance Monitoring, which allows you to gain insights into the real user experience of your app and help to identify opportunities to improve it. Performance Monitoring supports 3 platforms: Android, iOS, and web. We are going to walk through an example web app today, but the basic concepts we learned here can also be applied to the other platforms. So don't worry if you have your app developed for Android or iOS devices. You can find the Codelab link here and in the description below, so you can follow the step-by-step instructions at your own pace. Recently, I have been staying at home most of the time, and I want to stay connected with my friends around the world. So I used this friendly chat app from Firebase Codelab repository and shared it with my friends and family. But my friends in Europe found it takes a long time to load the web page, and my friends in Asia told me that uploading an image is very slow. Why did it happen? The web page is loading fast enough on my machine. To figure out what's happening in my friend's situation, let me use performance monitoring to measure the app performance as experienced by them. Okay, let's open the Codelab link together. To start the Codelab, let's check whether we have everything we need for development. The IDE or test editor of your choice. I'm going to use VS Code for the live demo today. A terminal or console, because you will need to run Git to get the sample code for this Codelab, and use the Firebase CLI to deploy your app, and a modern browser of your choice. I'm going to use the latest version of Chrome today. Once you have all the prerequisites in place, let's download the sample code as step 2 of this Codelab. This is the source code of the chat that I mentioned earlier, which we'll call it Friendly Chat. It allows users to sign in with their Google account and chat and share images with each other. Now, I'm going to run this command in a terminal to download the sample code. While we are waiting, you will find the GitHub repository consists of multiple directories. This repository is used for multiple Codelabs, and we are going to focus on Performance Monitoring Star, which is the starting code for this Codelab today. But feel free to check out other Codelabs if you are interested. They are quite fun and helpful. After the download is done, you can open the Performance Monitoring Star directory of this GitHub project in your IDE. It has already implemented the basic functionality of the friendly chat app. They are in public directory. You can find more in index.html file and the main.js file in the script directory. However, you will need to enable the backend using Firebase for it to work. We are going to walk through it together in the next step. Now, let's create a Firebase project. Click the link at step 3 to open the Firebase Console. This is the place where you manage all of the Firebase services your app uses. Our friendly chat app needs to be associated with a Firebase project. So let's create that now. Click Create Project. You can give any name for the project, for example, Friendly Chat. Please note that it will automatically generate a project ID for you. We will need this ID later on when using the Firebase CLI. So it's not a bad idea to write it down. We are going to skip Google Analytics for now, since this is not part of the Codelab. but we can always enable it later to get insight on the user action in our app. Google Analytics is used for analyzing user behavior and traffic flow, while Performance Monitoring is used for measuring aggregated app performance. Now that the Firebase project has been created, we need to add a web app. You can see from the dashboard that there are iOS, Android, and web options. We are going to select Web. In the app creation flow, we are going to give it a name. Again, you can give it any name you like. I'm going to name it Friendly Chat. I also need to deploy the app to Firebase hosting, so I'm going to check this box. The console tells us that our app needs these 2 lines to integrate with Firebase. However, they are already added to the sample code, so we don't need to do that here. We will also skip the CLI and deploy steps, since they are already covered later in the Codelab. We have successfully created a web app in Firebase. That's cool. But we are not ready to see a working app quite yet. We still need a database to save chat messages and a place to store images. In the Firebase Console, we are going to use authentication for Google Sign-in, database for storing messages, and cloud storage for storing images. If you would like more information about why we picked each service and how they work, check out the Firebase Web Codelab YouTube video. For this Codelab, we are just going to quickly enable them to get the app working. To set up authentication, let's go to the Develop section in the left panel. Click Authentication, then click the Sign-in Method tab. Here are all the different sign-in providers supported by Firebase Auth. You will see all the popular ones here: Google, Facebook, even phone numbers. We are going to use Google Sign-in for this Codelab, so let's click that. All we need to do is to toggle this top option to enable, and provide an email address for support. Then click Save. Then let's click Database. We are going to use Cloud File Store for storing chat messages. Simply click Create Database, and you will be able to configure an instance for your database. I'm going to start in test mode. It means that our website can read and write to our database even without sign-in. So it's an easy way to get started with Firebase and building an app. But make sure that you set up proper security rules for your actual app to protect your data. At the last step, I'm going to select the location for my database. Please note that the location cannot be changed for this project once configured. I'm going to select US Central. And my database creation is done. Now, we are going to enable cloud storage for storing files, such as images. Let's click Storage, and the creation flow is very similar to Cloud File Store. Let's click the Done button. Awesome! Now my Firebase backend is all set up. Let's come back to the Codelab instructions. We will need Firebase CLI to deploy the app's code to Firebase hosting. You can follow the instruction in Codelab to download the Firebase CLI. In my case, I just download and run the library. After download, I ran this command to check that I have the latest version of Firebase CLI. Version 8 or later is good for this Codelab. Let's log into our account so we can access the Firebase project we just created. After login, let's make the CLI's active project to be the project that we just created. I'm going to run this command here and select the project I created. Remember that this project ID was shown in the Firebase Console previously when I was creating a project. Here, you can give it any alias you want. I'm going to call it Friendly Chat. Now it's time to use Performance Monitoring. I'm going to open the sample code using VS Code. and go to public/index.html file. Double check that the Firebase app.js and init.js are included in the script tag. Then make sure you initialize the Firebase library so that it can talk to the services we created earlier. Then, add the following line to integrate with Performance Monitoring. You can also search to do to quickly find the code location. Now, let's go to scripts/main.js file. We are going to initialize performance by adding this line. Again, you can search by to do to quickly find the code location. And that's all we need to do to set up performance monitoring. After we deploy our app to Firebase hosting, Performance Monitoring will start collecting performance metrics right away. Deploying to Firebase hosting is simple. Let's go to the terminal and run Firebase deploy. Remember to run this command within the Performance Monitoring start directory, so that hosting gets the files associated with this app. Once the deployment finishes, we will be able to see a link to the website. It's going to be exciting. Now the deployment is successful. Let's open the website. Now your app is live. That's amazing. Right now we are going to check the Firebase Console. Let's go to the Performance tab. If you see this page, congratulations! Firebase has received your performance event and is now processing it. At this point, the metrics about web page load and network requests are automatically captured. This should allow me to monitor the page load taking a long time issue for my friends in Europe. What if we want more? We can also capture advanced performance metric. Let's take a look at this concept. First input delay. This matrix measures the time duration between the first interaction from the user and the browser being able to respond. It can tell whether your app is lagging to users' input. It's really important. The Google Chrome teams named this as one of the core web vitals. It must be optimized for a good user experience. So why doesn't the Performance Monitoring SDK support this out of the box? Well, first input delay is not supported by all browsers, so we need to add a polyfill. Simply go to public/index.html and uncomment this line. And you should be good to go. Please note that first input delay polyfill is optional. You don't need to do this if you don't want to collect this metric. Each app has its own behavior, so Performance Monitoring provides a customization feature on top of the out-of-box matrix offering. If you remember from earlier, I need to monitor the image upload speed for my friends in Asia. Let me use an API called custom chase to do this. The basic concept of a custom chase is that it's a timer. So you just need to call start and stop to measure the time duration between two events in your code. In my case, I want to start a timer when the image starts uploading, and stop it when the upload is complete. Let's start with creating a custom chase. Go to scripts/main.js file and search for the function which uploads an image. I'm creating a custom chase called saveImageMessage. This is pretty straightforward and I can use it to measure the time duration. Then I'm going to call start and stop. Note that I call start before sending the upload image request and call stop after the request is complete, which measures the time it takes for image upload. If I call stop before the start, this custom chase will not be recorded. Now our app will measure the length of time it takes to upload an image. But we can do more with custom chases. Our chase can also record extra information, called matrix, so that we can debug the image uploads. In the example here, the slowness of an image upload might be related to the size of it. So let me record the image size by calling putMatrix. Remember to add the matrix before calling chase.stop, since traces and their matrix data are reported back to Firebase once they are stopped. How do I segment the custom trace data? Although we captured the image upload time and size for all custom traces, we might not be able to tell the root cause of the issue without slicing this high-volume data into subgroups. I wonder whether the image type is relevant to the upload slowness. So I'm going to use a performance monitoring feature that lets me tag these custom traces with different labels, called attributes. I'm going to call put attribute with the name image type, so I can filter by PNG or JPG later on the Firebase Console. And again, make sure to add them before calling stop. Now we can be confident that we are measuring everything we need to diagnose the image upload speed problem. We have a custom trace to measure the time it takes for each upload in the real world, and we record a matrix of file size and an attribute of file type. Let's talk about the performance of Performance Monitoring SDK itself. The SDK won't be helpful if adding it can slow down the page load. That's why it was designed so it could be loaded asynchronously. It will even capture matrix like page load and network requests that happened before the Performance SDK was loaded. But how about custom traces? How do we capture a custom trace if the Performance SDK is not available? No worries, you can use the browser's built-in user timing API to capture a custom trace, and they will be picked up by the Performance SDK once it's loaded. In our example, I suspect the page load slowness has something to do with the style sheet loading. Let me add a custom trace with user timing API. Go to public/index.html file and add this line before loading styling script. And then add the following code to mark the end of custom trace and name it load styling. Again, notice that I'm not using the Performance Monitoring SDK here, but rather the built-in browser user timing API. Now that a custom trace using user timing API is created, and the other custom traces are added to our app, let's deploy to Firebase hosting so that our users receive our newly instrumented app. Let's run Firebase deploy again, so we can pick up the changes we just made. Don't forget to save them before deploying, and clear the browser cache if you want to see new changes. Since I used the user timing API for the style sheet load, I can actually view the trace in Chrome Developer Tools Performance tab. But to see the aggregated data from everyone that used my app, I will go back to Firebase Console. Since we collect a high volume of performance events, we need to wait some time for the data to show up. But Firebase is going to support real-time data processing soon, so looking forward to that. While we're waiting for Firebase to crunch the data being reported by the new friendly chat app, let's take a look at the same app I built before and deployed it to a different project. You can select up to 90 days of history data. This app has the data populated on the console, and we can see that the network latency is slow in Europe, Asia, and America, which explains what my friends told me. By the way, we are working on refreshing the dashboard content, so stay tuned and come check out the new dashboard when it's ready. Let's click the On-Device tab and check out the page load trace. Performance is a multi-dimensional concept, and there's no single metric which can tell whether your app is fast. So Performance Monitoring provides 6 out-of-box metrics for the page load trace. First pane, the first pixel to be painted on the page. First contentful pane, the first content to be painted from the DOM file. First input delay, which we have explained before. And there are 3 other metrics which are related to the lifecycle of DOM loading. I can also select aggregate or over time to observe the time duration percentile for performance improvement or regression. Now let's see what's inside the custom traces I created. You can see that both the load styling and save image message are captured here. Let's click Save Image Message and check out its custom matrix. By default, there's a duration matrix which captures the time span from start to stop. And we added a custom matrix called Image Size. Looks like my friends are uploading images with huge difference in sizes. Let me look deeper at duration. Performance monitoring automatically collects default attributes like browser, country, connection type. And our custom attribute is image type at the bottom. Let's check that out. Looks like the GIF type is taking longer than the JPG to upload on average. Maybe I can limit the upload type and compress the image before uploading to improve the user experience. Finally, let's walk through the network tab. This has captured the response time for all network requests sent from your app. Note that they have ** and * in the URL. That's because we group URLs with a similar pattern to make performance data more meaningful. If there's any pattern you are looking for in your network requests, you can click the Create Custom URL Pattern button to group them to the patterns of your choice. Congratulations! You have successfully integrated with Performance Monitoring. And after improving your app based on the information from Performance Monitoring, your friends no longer need to wait for a long time to load your app. If you want to learn more, check out the links here and the description below. If you find this coding section useful, or if you want to learn more for your use case, feel free to let us know and subscribe to Firebase YouTube channel. We are looking forward to hearing your story and can't wait to see the great apps that you build.